Hello. So we are back for chapter 3 of this wonderful book where I spent last year working on the L functions, Dirichlet L functions and L functions of elliptical curves, and learned a lot, very nice. Spent the summer working on my physics project. Now it's time to work on modular forms. So welcome. Prove it's a normal subgroup. I'll do that by explicit computation. Normal means that the inverse of G times the subgroup times G equals the subgroup. It's sufficient to show that it lies in it, as part of it. So let's try to do that explicitly. Gamma naught, it has the form ABD minus first, and then 1, 1 modulo n. Working modulo n, yeah, that should do it. That means that I actually takes gamma naught of n and gamma 1 of n and project them to SL2 of n and their projections, and then if that's normal, then it's just the projection modulo n. So that'll work doing that. Subgroup of gamma 1. It's any number up here, x like. And then the inverse of that guy, I'll just have to work on that. And I'll make a break and work on that and then start again. The next problem, whether gamma naught is a normal subgroup, then we have to try the same condition, and gamma is generated by S and T, so it's sufficient to try this with S and T. So I'll do that as well, make a break, and then show you the result. I have now performed the calculation, and let's try to check the result. This is a multiple of n, and it ends down here again, so that means that it does lie in gamma 1, meaning if you multiply it with some member of gamma naught, it fulfills the normal condition. So that's the first one. And the second one, oh, I didn't do that. I need to do that as well. I'll do that in general, but let's first check the last one where my intuitive answer was no. So I applied S on both sides. It's a reciprocal. And here instead of writing naught, I actually wrote Cn, and then we get B down here. So does there exist an n a matrix in gamma naught where this is not a multiple of n, then it's not normal, and that's obvious because this is equivalent to 1 modulo n. So this is still equivalent to 1 modulo n. So that actually only shows there's 1 modulo n. So I should give an explicit example to prove it for any n where this guy is distinct from naught, and this one is or is not a multiple of n, whereas this guy is. So that's two things I just have to work on. All right, that was the calculation. Now I have learned how S transforms a matrix, so I could write up the result pretty easily. And -1 might give unity if n equals 2, but still we need to find a matrix with a B that does not divide n, and it has to lie in gamma naught. And down here in gamma n. Now this guy in gamma naught, that may just be the matrix. What's wrong here? Well, I can say it without writing it. It can be T itself, 1, 1, 1, naught. Then we get a unity down here, which cannot vanish. So that shows that this does not lie in gamma naught. And then we have to show that this does not lie in gamma 1 is not. Oh, we can do the same here. It's T as well, we can use this example. So one has to work a little with it and just apply the definition, and then there are some problems here in the start where we have to do some basic fiddling around with these groups, I think.